So today we're going to look at the equation C1V1 is equal to C2V2 and why this equation would be important. So let's use the example that we have our stock solution. So we get into our cabinet and we have our 12.1 molar stock solution of hydrochloric acid. So it's very dangerous, very deadly. It's very corrosive, and it's also not very useful. So it wouldn't make sense to use this. But instead, we want to go ahead and make a 500 milliliter solution, and here's our little 500 volumetric flask. So we want to make 500 milliliters of something that's more useful, or 1 molar hydrochloric acid solution. That way we can use this for our further reactions, maybe a lab we have, whatever. And in order to do this, what we'll need to use is the C1V1 equals C2V2 equation. So what does that stand for? So C1 is for the concentration of the initial condition. So C1 is our concentration of our start, or our hydrochloric acid. So this would be 12.1 molar. This would be equivalent to C1. Now our V1, that's what we want to find. So this would be how much we need to add to water in order to get this new concentration. So that would be our X. C2, of course, would be the concentration that we want to have. So 1 molar hydrochloric would be our C2. And our V2 would be what volume do we want. And in this case, that would be 500 milliliters. So this is the volume that we want. So we go ahead and plug this into our little equation. So we've got 12.1 molar times X. X is what we want to find. That's our volume of our stock solution that we want to put into water in order to get our new solution. So we'd have 1 molar and 500 milliliters. So commonly you might see this as liters instead of milliliters, right? But if we left this in milliliters, we could change it to liters or leave it in milliliters, and the units will work out. So when we divide this side by 12.1 molar, divide this side by 12.1 molar, or molarity that is, you can see that units of molarity will cancel out with each other because one's on the top, one's on the bottom. And what we're left with is units of milliliters. So we go ahead and find that X is equal to 500 over 12.1, or more simply, X is equal to 41.3. So I went ahead and did that in my calculator earlier. So what this tells us is that we need 41.3 milliliters of our stock solution. Then we add that to our volumetric flask, dilute to the mark with water, and that would give us our 500 milliliters of 1 molar hydrochloric acid. So in order to do this, what we would do, we'd go ahead and get our, preferably a 50 milliliter graduated cylinder. So here's our graduated cylinder. We got 50 milliliters right there. And then, we'd have our 40 milliliters right there. And if we zoomed in, we could see that we have 41 and 42. So an expanded version of this, right? Here's our line for 41 milliliters. Here's our line for 42 milliliters. We'd want the meniscus to be right about there, so just around 41.3. And you could use a dropper to try to get this last way, depending on how accurate you need to be. But then once we had this 41 milliliters of acid, we could dump this into our volumetric flask. So acid first, obviously. We put a little bit of water in first, so a little bit of deionized water. Put in the hydrochloric acid, and then fill up to the mark. So there'd be a white mark right there. And just like before, if we expanded this, so here's our white mark. That tells us exactly what 500 milliliters is for this particular flask, and we want the meniscus right on the tip of that mark. And we'd use a dropper or something fine-tuned in order to put those last few drops of deionized water in order to make this. So this is why the C1V1 equation is important, because it's a very useful tool in chemistry, especially when you're trying to make stock solutions. So that's all I have for you today. Thanks for tuning in.